see, we did percent and proportion review last time. So let's go check out conversions today, page 41. All right. Use a calculator with scientific notation. So we're doing review on page 41. These should be pretty easy for y'all by now. It's just a matter of entering this stuff into your calculator correctly. Again, we could use Wolfram Alpha. And if you have a laptop in front of you and internet access, then you can go here. So let's see. Negative 1.53 and 4.57. So, negative 1.53 times 10 to the third. And they want us to add to that plus 4.57 times 10 to the third. All right, something like this, we can just type it in from left to right, just like it is on the screen there. You know, just like it's listed here. We just type it in exactly that way. The software will automatically multiply first and then add. So we get 3040. Right, this is 3040. Right? You gotta do the multiplication first and then the addition. Or you can move the decimal yourself without using a calculator. This would be a negative 1, 1, 2, 3, and then a plus 1, 2, 3. All right. So, same thing with this one. You type it in just the way it is. This one you don't even need the parentheses. It's all multiplication. All right. A times B times C times D. That's A times B times C times D. Or A, B, C, D. That's how most of us would write it. All right. So this one, if we're going to type it in, we have to be kind of careful because we are going to have to put parentheses when we enter it in because we don't want it to do this. If we do that and then we do the divided by or that, if we just type that in, we wouldn't get the right answer. Just typing that, the computer is doing that. We're going to have to put these parentheses here to get the correct answer. Okay? Because A times B divided by C times D, that's going to be AB over C. And then the times D, it's putting the D on the top, but we need it down here. So to get that down here, we'd have to do that. So 5.47 times 10 to the third divided by 1.76. Divided by parentheses 1.76 times 10 to the negative third. All right, we got 3.12 times 10 to the sixth. All right, which kind of makes sense. Notice this is a 10 to the negative 3. That's the same thing as putting it up here as a 10 to the positive 3. So we would expect a 10 to the 6th. 10 cubed times 10 cubed is a 10 to the 6th. All right, for a quick rough check, if the answer makes sense.
Yes, sir.
Any questions about this stuff? Can y'all handle this?
Yes, sir.
All right. Let's see. All right. We're going to need our conversion chart. I'm not sure if I remember all these. Like, what is that, a megaliter? So let's see if we can find it. There it is. Where's that capital M? Yeah, mega. It's into the 6th. All right, so number 6, a nurse needs to give a patient 0.0025 grams of Valium. All right, convert this to scientific notation. That's 2.5 times 10 to the, let's see, negative 1, 2, 3. All right, a negative makes this number smaller. Move the decimal to the left. All right, convert it to milligrams. This is grams. So to convert it to milligrams, that's 10 to the negative 3, right? So to convert it to milligrams, we got to get grams. We need milligrams. There's 10 to the third milligrams per gram, or 1,000 milligrams. That's why it's called milli, like a 1,000. So the grams go away. 10 to the third, 10 to the negative third times 10 to the third cancel. We get 2.5 milligrams. Now convert it to micrograms. That's what this letter is called, mu. Micrograms. So 10 to the negative 6. So we have 2.5 times 10 to the negative third grams. Get rid of grams. We want micrograms. There is 10 to the 6th micrograms per gram. So we got 2.5. 10 to the negative third, 10 to the 6th gives us a 10 to the third micrograms. Which is the best way of expressing this dosage? I'd say milligrams. Hold on a second, I'll be right back. Dexter, you have your own door. I'm scratchy. No, puppy dog. All right, let's see. Number 7, we're going from liters to, what is this, milliliters? Where's it? Milliliters. Again, that's 10 to the -3. So we take our liters here. We want to get rid of liters. We want milliliters. And there's 10 to the 3rd milliliters per liter. The liters go away, and we have 0.5 times 10 to the 3rd milliliters. Oh, they already got the milliliters there. What we want to do, though, to put this in scientific notation, we want to move that decimal over. We want this to be 5 times 10 to the something, right? I want to make sure I move the decimal in the right place. Let's see, this would be 500. Wait, 1, 2, 3. 1, 2, 3. That would be 500 milliliters. We need it to be 5. So that would be 10 to the 2 milliliters. Right? Yeah. So these are all equal. Something like this, the chart doesn't tell us how many centimeters or how many millimeters are in a centimeter. It tells us how many centimeters are in a meter and how many millimeters are in a meter. So what we can do with something like this is get rid of centimeters, convert it to meters, and then get rid of meters in favor of millimeters. There's 10 squared centimeters per meter, and there's 10 cubed millimeters per meter. So the centimeters cancel, the meters cancel. We're left with our millimeters. And we have 10 to the 3rd over 10 squared. That's just 10, right? So we have 16 times 10. But since it's only a 10, we may as well just write that as, I forgot my millimeters. This is just 160 millimeters. There's really no need to write that in scientific notation. And we could, this would be 1.6 times 10 to the 2 times 10 squared. But that's a lot more writing than just writing 160, right? So typically you wouldn't use scientific notation to write 160. Let's look at number 10 here because it has the squared. Let's do it in its own spot so we have enough room to write things out. All right, recall when we have things squared like this. All right, we're going to multiply this by the number 1. We got to get rid of meters twice, right? All right, we're changing it to centimeters, but it's squared, so we need centimeters twice. All right, so let's see, there's 10 squared centimeters per meter. All right, so we get meters squared cancel. So we have a 4, it's 10 squared, 10 squared, centimeters squared, or 4 times 10 to the 4th. All right, y'all can handle these kinds of problems, right? Where you get the squareds or the cubes.
Yes, sir.
All right, if it was cubed, you'd have to have 3 of these.
So however much the exponent is, that's how many parentheses you would put.
Yeah.
Yes, sir.
What if you had something goofy like, let's say, $4 micrograms per liter. and we want to convert this to cents. Let's see, cents per milliliter, and I need a weight here. Money weight, liquid, money weight volume. Let's see, let's do megagrams. How would we do this? All right. It's a strange problem, right? Well, let's focus on one unit at a time. We have money, weight, and volume. So let's focus on changing each one individually. So we got to get rid of dollars in favor of cents, right? We know there's 100 cents per dollar, right? Now let's focus on the weight. We got to get rid of these micrograms, and we want megagrams. But I don't know how many micrograms there are in a megagram. I know how many micrograms there are in a gram, right?
Yes, sir.
And that would get rid of that, and then I got to get rid of grams. I know how many megagrams there are in a gram, right? So that got rid of the micrograms, turned it into grams, got rid of grams, turned it into micrograms. I know there's 10 to the 6th micrograms per gram, and I know there's 10 to the 6 grams per megagram, I think. Or is it 10 to the 9th? Yeah, mega, 10 to the 6th. Okay. So, see, I got rid of dollars in favor of cents. I got rid of the micrograms in favor of megagrams. Now I want to deal with liters. We want to convert that to milliliters. So, since the liters is on the bottom, I got to get a liters on the top, so they'll cancel. Per milliliter, I know there's 10 to the 3rd milliliters per 1 liter. So I have a 4 times 100 over 10 to the 6th times 10 to the 6th times 10 to the 3rd. That's going to leave us with our cents and then our megagrams per milliliter. So let's see here. We got 4. All right, this is 10 squared. And then these are on the bottom, so they're negative, right? Negative exponents. 12, 13, 14, 15. 4 times 10 to the negative 13 cents megagrams per milliliter. So could you handle something like that?
I think so.
Is that pushing it? It's the same process.
Yeah, I guess it's just kind of like plugging in more so.
Yeah, you're just doing the same thing over and over again. You just focus on each item separately.
Yes, sir.
So this is like 3 problems in one, right? Just focus on each unit separately. You just got to recognize the types of units, right? You can't convert a weight to a volume, right? Like you can't convert like meters to liters. That doesn't make sense, right? So you have your lengths, your weights, and your volumes. So you convert in between those. If you start off with dollars and you end up with meters, you're doing something wrong. That's why it's important to always write your units when you're doing any kind of problem at all. The units guide you. They help you, the structure of the math, they help you set up your formulas and such.
Yes, sir.
remember like these ones, all right? The amount here, right? P here is in dollars. Your amount needs to be in dollars. But over here, think about the units that go on over here. N is the number of times, all right, number of times compounded per year. Compounded per year. See that per year? And then T is number of years. So that NT, the units, the N is per year, right? That's year on the bottom, and time is year on the top as far as just the units, and they go away. So NT is just a pure number without units. It's a dimensionless number, right? Same thing with R over N, right? R over N. The per year on the bottom, the N, that would put the year on the top. But the rate is percent per year. All right. So that per year puts a year on the bottom. Those cancel, and it's a pure number. So that's why the only unit that shows up on each side is dollars equals dollars. The units here cancel out, the units there cancel out. Now let's do quiz. Number 25. Let's see. Let's do some easy ones here today. Or since we're going to work these in class, let's go ahead and look at those exponential ones.
Yes, sir.
Like 197 or something. Yeah. So for an exact answer. So this one. And let's see, what do we have down here? This one. All right, let's take 15 minutes. So that would be 3:41. We will reconvene.
Yes, sir.
Recording. All right, number one. See, we have this x up here in the exponent, right? So first, let's isolate the exponential by adding 7 to both sides. So it'll be 11 to 50. Now, in order to get that out of the exponent, since it's a base e, we'll take the natural log of both sides. Okay, so the natural log and the e to the undo one another. We get a 4x minus 5. So the natural log 11 to 50. So add 5 to both sides. 4x equals this bad boy, and then a 5. Now divide both sides by 4. We have x equals all of this divided by 4. Did y'all get that one? Is that what y'all got?
I guess I was a little off track. With it, I got messed up with the plugging in.
So are we still got time for you to become a master? Let's look at number 2 here. Need more space. All right, if the money grew to $12,000, money grew to that amount. So that's our amount. And it grew to that, invested at a simple interest on investment of $10,000. In 5 years. What is the interest rate? So simple interest is I equals PRT, right? So let's see, our amount is our principal plus interest, right? P plus PRT, okay? Therefore, and we can rewrite this as P the 1 plus RT, all right? We haven't done many problems like this, but it's the simplest one, you know. The amount is the principal plus the interest. The interest is your I par T formula. So your amount becomes that. So the amount is P times 1 plus RT. We need to solve for R, right? So solve for R. So let's see, if we divide both sides by P, we have A over P equals 1 plus RT. So therefore, RT is A over P minus 1. Therefore, R is 1 over T, A over P minus 1. So T here is 5. A is 12,000. P is 10,000. So let's see, we have let's see, 12,000 divided by 10,000 minus 1. This is 0.02. All right. So 0.02 divided by 5 is 0.04, or 4%. All right, how'd y'all do on this one?
That one I didn't know, so that's why I wanted to have help on that one.
All right, does it make sense now though? I mean, most of the problems are like find the amount, right?
Yes, sir.
And then some of them, they're giving us the principal and all that, and we have to find the rate or the time or the principal, right? So here's our formulas, right? We have simple, I equals PRT. So the amount is principal plus interest, P plus PRT, or P times the 1 plus RT, right? You want to be able to rearrange this. A equals P. You want to rearrange it where you have P equals or R equals or T equals, right? Depending on what they ask. We already have what A equals. If they give you PRT, you plug it in, right? But I just showed you how to rearrange it. Y'all know how to do basic algebra by now. Y'all can solve for, we just solved for R, right? You can do the same thing for T or P, right? P would be A divided by 1 plus RT, right? That gets P by itself. We just found R to be this. That was R. Or if we're going to solve for T, let's see, from right here, instead of dividing both sides by T, like we did here, we divide both sides by R. So T would be that. All right. Then we have compound interest, right? Interest. A equals P 1 plus R over N to the NT. All right. All right. But what if they ask you for the principal? They give you the amount, you have to find the principal. Well, it would be A and divide by all of this, right? Well, dividing by it is the same thing as having a negative exponent. All right, so if they give you the amount and they want you to find the principal, you use that formula. They might have you solve for the time here, but it would be easier just to plug the numbers in and take a log. So I don't expect them to do that. If they give you continuous, yeah, amount equals P e to the RT. So if they wanted what the principal is, they gave you the amount, divide both sides by e to the RT, right? So that would be that, right? The negative means you're dividing by it, right? Or if they wanted R, right? If they wanted R, you'd have e to the RT equals A over P, right? Divide both sides by P. And then you take the natural log of both sides. So you get RT equals natural log of A over P. From there, if you're looking for R, you divide by T, right? R would be 1 over T, natural log of A over P. Or if you wanted the time, this would be 1 over R, natural log of A over P. Okay, so depending on what they ask, I mean, these are your three basic formulas, right? That one, and that one. But you need to be able to rearrange them for any one of the variables, which we just did for all the possible variables. So can y'all do that? Can y'all rearrange these? Can you rearrange that to solve for R or T or P?
I think so, sir.
All right. So back to review then. Forgot what page the review was on. Oh, hold on a sec. Hey, baby girl. Sit up. Sit up. There you go. There you go. I'm babysitting today. 41. That's where we were. And to be all right, inches, centimeters. I don't remember if we had a chart for those. Here we go. This guy. So let's pick out some of these. This is an interesting one. Gallons to inches cubed, right? Gallon is a volume, right? And a volume has dimensions of length cubed. A length times a length times a length gives you a volume. So when you see things that would refer to an amount of a liquid, they're talking about the volume, right? So you can always convert a volume to a length cubed. So if we wanted to convert this 102 gallons, right? Let's see. Here's gallons, quarts, liters. I'm gonna have to look it up. Let's see here. Here's a liters to meters cubed. See that? So if we can convert gallons to liters, then we can convert liters to meters cubed, and from meters cubed, we can go to inches cubed. So let's try that. Let's see what we can do. So we want to get rid of gallons in favor of liters. And then up here we can get rid of liters in favor of meters cubed. But now we got to get rid of the meters. We want to end up with inches, right? So let's see. Meters. Well, here's our conversion between inch and centimeters. So let's get rid of the meters cubed in favor of centimeters cubed, right? But how do we do that? We'd have to do the meter, centimeter 3 times, right? So that wouldn't cause that, right? Already did that. Already did that. So we've got it to centimeters cubed, but we want inches, right? So they tell us here, we're gonna have to do it 3 times. We got to get rid of centimeters in favor of inches. All right, centimeter, 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 centimeters. We're going to end up with inches cubed. Now we just have to fill in the numbers, right? All right, that was the hard part. All right, y'all follow that part so far? Trying to go from gallons to inches cubed. So I just picked out what I could. I went from gallons to liters, and then liters to meters cubed, and then from meters to centimeters, and then from centimeters to inches. So let's look at this, gallons and liters. Let's see, 1 gallon is 3.79 liters. All right, so up here we have 1 liter is 0.001 meters cubed. All right, and I know 1 meter is 10 squared centimeters. 1 meter, 10 squared centimeters. 1 meter is 10 squared centimeters. Now, see, 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. 1 inch is 2.54. 1 inch is 2.54. So we have 102 times 3.79 times 0.001. All right, that's 10 to the 6th. And then we have on the bottom 2.54 cubed. We're left with inches cubed. Hold on a second. What's wrong, baby girl? Oh, gotcha. Gotcha. Okay. There you go. All right, and the rest of this is just plugging it into your calculator, which we can do in Wolfram here. We had 102 times 3.79 times 0.01. All right, times 10 to the 6th. All right, and then we're dividing by 2.54 cubed. So now divide by 2.54 cubed. And let's see, we're getting 23,590.59. Does that make sense? 23,500. 23,590.56. Inches cubed. That sounds reasonable. I mean, 102 gallons takes up a lot of space, right? So we're not talking about 23,000 inches. This is inches cubed, right? So that's so many inches by so many inches by so many inches, right? If we took the cube root of this, that would kind of give us the length of the box here. So let's see if we can find cube root of, I'm just going to do 24,000. Let's see, how would I do that? Cube root, that would be to the 1/3 power. So 24,000 to the 1/3. Right, a square root is a 1/2 power. A cube root is 1/3 power. So 28.9. So let's say just 28. So that's like a box. That's approximately 28 inches on one side, right? For 102 gallons, you know what 28 inches is? What, let's see, about 2.5 feet. So a box 2.5 feet by 2.5 feet by 2.5 feet would hold approximately 102 gallons, according to these calculations. Is that making any sense?
Yes, sir.
All right. So you can handle a calculation like this. Just again, you're just focusing on each unit, you know. And here it's gallons. We just had to, you know, make our way to inches by following the chart. So let's see. Let's pick another one. See any other ones in here you'd like to try out?
Number 34, or not 34. 35.
35. All right. So we have miles per hour, 60 miles per hour, right? And we got to convert that to meters per second. All right, so we need a conversion between miles and meters. Let's see. Oh, we got miles per kilometer. So 1.6 kilometers is 1 mile. So miles, kilometer. What was it? 1.6 kilometers is 1 mile. I done forgot. Yeah, 1.6 kilometers is 1 mile. So since it doesn't tell us meters, right? We got to get rid of kilometers and we want meters. Well, I know there's 10 squared meters per 1 kilometer. So I got rid of miles, get rid of kilometers. I'm left with meters. Now I got to deal with hours. I don't know how many seconds are in an hour, but I got to put hours up here so they go away, right? I know minutes per hour, and I know seconds per minute. All right, we got to get seconds on the bottom down here. So let's see, there's 60 minutes per 1 hour and 60 seconds per 1 minute. Bless you, little one. All right. Get down, dog. Okay, okay. That's your choopy. All right. So we got 60 times 1.6, 10 squared over 60 times 60 meters per second. Oh no. See, the 60s here can go away. So let's see, 1.6 divided by 60. 1.6 was it times 10 squared divided by 60, 2.67. That didn't make sense. Yeah, I guess it does. 2.67 meters per second is 60 miles an hour. All right, hold on, little one. I dropped your pacifier. Oh. Hey, want to see my baby girl? Oh. Say hi to the class. She's hairy. All right, any others from this section? I'm gonna do like 39 here. Looks complicated. All right, we got grams per centimeter squared. So we need to go from grams to milligrams. That's easy enough. Grams, milligrams. Let's see, there's 10 to the third milligrams per gram. All right, we got to go from centimeters to millimeters squared. So I don't know centimeters to millimeters. I know centimeters to meters. We have to do it twice because this dude's squared. And then I can go from meters to millimeters. I have to do that twice. Right, centimeters go away, then meters go away, and we got our millimeters squared on the bottom, and our milligrams on the top. So 10 squared centimeters per meter, and there's 10 cubed millimeters per meter. So I got an 8.24. I got, let's see, on the top, I got 10 to the 3, 4, 5, 6, 7. And then on the bottom, I got 10 to the 6, so negative 6. So that's 8.24 times 10, which would be 82.4. Oh, I forgot to write my units. Milligrams per millimeter squared. All right, any questions about that one? Can y'all handle the unit conversion? Or do we need to come back and do more of these next time? Maybe some of these word problems, right?
Yes, sir.
All right. So let's have exam number 25, right? Yeah. Let's see. So from 197, let's do 24. And I'll do 24 and 25. Okay. And let's get these in by midnight. I will see y'all on Wednesday.